Problem 10 on the homework handout. This is homework 8, chapter 20, linear momentum. Problem 20.9 deals with the collision between two vehicles. One is a two-ton vehicle traveling at 60 miles per hour. You assume they have a collision at an intersection when their velocities are, say, 90 degrees away from each other. And let's assume the truck is moving toward the north. 10-ton truck traveling at 30 miles per hour. So 60 miles per hour, 30 miles per hour. Since momentum is a vector quantity, we'll have to take that into account in our solution to this problem. Afterwards, you assume they have an inelastic collision, they stick together, and they're asking us to figure out what the velocity is after the collision. Alright, so you can say that the initial momentum vector is equal to the final momentum vector because there are no external forces. You say the system is the vehicle, the 2-ton car and the 10-ton truck. That's your system. If you do that, there's no external forces, so you can say this is equal to that. This is the one problem in which you will have to look at the vector nature of momentum. So we use I hat to indicate this one is moving in the x direction. We'll say that the 10-ton vehicle is moving at 30 meters per second in the j hat direction. All of this, by the way, is just the initial momentum, and that's equal to the final momentum, which is 12 tons. I'm adding those two masses together, times the velocity final, and I'm going to put a vector sign on that. What you'll need to do is divide both sides by 12 tons and figure out what V final is by finding the magnitude of this vector. So you'll have to divide both sides by 12 and then look at the x component and the y components. The sum of the squares, square root. So we have an x component squared and a y component squared. It wouldn't hurt to go ahead and find the angle of that, so that would be theta is equal to the inverse tangent of the y component on the top divided by the x component on the bottom. The y component is this one divided by 12. The x component is this one divided by 12. So don't forget to divide by 12 up there. That's important, and the units will come out for your speed to be in meters per second. That's not right. It'll come out in miles per hour, and the angle should come out in degrees relative to the x-axis. Alright, so it's important to give magnitude and direction for this problem because it says find the velocity. It says find the velocity of the two vehicles, and velocity means both magnitude, speed, and direction, theta.